Our last presentation of the day before we get into the panel discussion will be shared by Yunzhe Yan, the Senior Technical Expert of TUV SUD Certification and Testing China. Yunzhe will share with us the key technical points of PV module reliability tests and eco-design of the modules. Yunzhe, welcome to Tayang News. The floor is yours.
Hello, everyone. Can you hear me?
Yes.
Great. Then I will share my presentation. So I hope everyone can see my PowerPoint right now.
Yes.
So it's Yan from TUV SUD. So today I'm going to discuss some key points of the PV module reliability and also eco-design. And here, some background about the development of PV module technology. Back to the history, actually, we have already experienced 3 times of technology revolution. From 2000, the first generation aluminum back surface module starts its mass production. Then come to the second generation, the time of the PERC, which already is getting to mass production stage. It has improved the efficiency a lot, as you can see in this table. However, the efficiency is approaching its upper limit right now. So here we are at the 3rd generation, which the N-type PV modules play a very important role, such as TOPCon and HJT. With this technology, actually, the efficiency improved again. However, it's still not in the upper limit, so have some space for improvement. With the new generation technology, there are so many advantages we have mentioned before. For example, higher power output, lower temperature efficiency. So it helps to improve the performance of the power generation and also lower the LCOE as shown before. However, with the development of technology, always come out some new concern. So it will be very important to design the high performance product with, which is very reliable. From the technical view, as usual, we will consider 3 key points for design PV modules, which is shown here, the safety, reliability, and eco-design. So reliability is the fundamental of safety and eco-design, and safety model is designed according to the IEC standard. And eco-design is related to environmental protection, so has caused a lot of market interest recent years. In the following slides, I will focus on the reliability and eco-design. Reliability. So what's the reliability and how could we verify it? Let's first look at the concept of the reliability. The probability that a product will perform its intended function adequately for a specific period of time or will operate in a defined environment without failure. For the PV modules, the intended function is to produce electricity. Specific period should be its lifetime, and the environment conditions are different and varies a lot. There are so many climate stress factors that can influence the reliability of PV modules, as we can show in the left diagram. such as ingredients, temperature, humidity, wind, gas, sand, salt, and so on. But for the PV module power generation capacity, we have two key points to evaluate this. The first one is the first year energy yield, and another one is the power degradation rate. There is a power degradation curve from a JA product. You can find the first year degradation percentage and also the following annual year degradation rate in this curve. The power generation for the first year, I will introduce how to calculate it in the eco-design part. So ideally, if we want to verify the reliability, we should first understand different failure modes of the PV module. So what kind of failure can occur during the module operation? From the International Energy Agency, they have a scenario which divided the PV module failure in 3 stages, as shown here. In different stages, the different failure will occur. For example, in the first stage, the infant stage, we call it, the model design defect will lead to failure very quickly. For example, the loss of RAM and the power-induced degradation. And in the midlife stage, another degradation occurs, such as delamination and the defect of cell interconnections. Those models are not can't meet its warranty lifetime in the following. So how could we verify it? Ideally, we can design some accelerated tests to accelerate this failure. So to verify the PV module's reliability and also safety in its lifetime with a shortened period and lower cost. However, it's difficult for the PV modules. First of all, the failure mechanism for the PV modules are not fully aware for so far. That caused some problems because the different stress factors that will interact or even counteract with each other. So it's not an easy task to find the adequate accelerated factors. The designed test can be false positive or false negative. And furthermore, there is another problem. That is, the combination of materials are different, and also the application environments are complicated. So there is not possible to find a unique accelerating factors to show the equivalency of the test time and the service time. However, we still made some progress in this area. Here you can see the example. Based on the Norris-Landsberg model, we found that 500 circles TC test is roughly equivalent to 25 years lifetime based on the solder bond footage. But it's still possible to find the earlier stage failure. So we call it qualification test, which is most of IEC standards do. So there are so many test standards which are published with IEC. We recognize these standards as qualification tests because we use these to find earlier failures and also to screen new design and new product with the known failure mechanisms. Here, I already listed some standards published in IEC. From the left column, there are the standards that is commonly used in the industry right now. And the left column, these standards are currently published and is still not widely used. So I would like to address important standards for the reliability for long term in this here right now. That's the IEC technical specification 63209-1. So these standards is intended to provide the supplementary information for the basic standard. We call it IEC 61250 from view of long-term reliability. In these standards, it considers 5 stress factors in how to say that 5 dimensions of the stress that PV module can suffer during its operation. These are, for example, thermal change and also humidity, UV, and mechanical stress, also power-induced degradation. So in these standards, it allows different extended stress testing protocols, so can reduce the test cost and also save the time for the industry. And what should be considered is also the application. Different application also have different factors need to be considered. For example, in the floating PV, the salt mist is very crucial. And for the dust and sand, it is worth considering when applied application to the area of desert. Last but not the least, some new trends. Here I listed 2 trends, which has caused a lot of interest for the last few years, and also IEC committee has put a lot of effort in this area to standardize it. The first one is operating at high temperature. In our basic standards, the PV modules, its operation temperature is up to its 98th percentile temperature, which is below 60 degrees C. And however, it's not enough for some BIPV, which operates at hot climate. So the material failure occur, and also serious hotspot, and even leading to some fire cases. So there is a standard, we call it 63126. In this standard, we stress the temperature factors a lot, with stressing the diode test and also the temperature limit for the material. So we can verify the PV module's reliability at higher temperature. And another one is LETID. I think many of you, I think, already have heard about it, because it cost many years studies and always being a popular topic. LETID actually will occur during the whole lifetime of the modules, and also because its degradation and regeneration happens together and combined together. So it will strongly affect the reliability and performance of the PV modules, which will cost a lot of loss. So the test specific for this scenario, for this problem is already addressed here. We can use this standard to define if the if the model is LETID sensitive or non-sensitive according to it. So here comes the eco-design part. Reliability is about the quality, but eco-design is more than that. It involves the environmental protection, the sustainability, and also which caused a lot of attention. What is eco-design? Eco-design considers environmental issues through the whole production chain at the product design stage. So, and also we use the we call it life cycle assessment methods to access it. Around here, we can see the idea of the production chain. It's from the raw material till the end of recycling. And also here lists some environmental issues that is related, for example, climate change and water use, human toxicity, ecotoxicity. As we know, about 6% of the product-related environment impacts are defined during the product design stage. So if we start to consider the environmental issues at this stage, it will improve the product design a lot and with an efficiency manner. Actually, European Union have worked on this area from 20th century, from the beginning of 20th century. It's quite earlier, around 1993. Energy labeling system is developed, and between 2016 and 2019, the European Commission considered to bring the PV modules and also inverters in the eco-design directive and energy labeling system. Also, the draft is already published. So here is the technical requirements in the eco-design directive. For the PV modules, we can see there are 8 aspects, but the most important are the first 3. The design for the reliability. It's regulated by the IEC standards, a basic standard 61250, and product carbon footprint. The third one, energy efficiency index. So let's talk about energy efficiency index at first. Okay, what's the energy efficiency index? Actually, in eco-design directive, it defines 3 typical climates in Europe, and the PV modules shall be classified according to its energy efficiency index values to different energy efficiency classes, and also based on 3 climate conditions. So still, what's the energy efficiency index? It actually shows how much energy a PV module generates at the first year per meter square. So it is actually calculated with the DC energy yield from 1 PV module over 1 year as usual first year divided with the module's area. There is progress to calculate the first year energy yield. It's according to IEC standard 61853. I'm not going into details. As you can see, it's related to the typical climate data and irradiance angle, also the mismatch of the spectra, the model operating temperature, and also the irradiance and temperature correlations. If you are interested about this calculation, you can check the IEC 61853 series for more details. So after we get the first year energy yield and we know the PV module area, and we can calculate the energy efficiency index. And what's the result at the end? It will put in the energy label. It will put in an energy label. So here is an example. In this label, the PV module shall be classified to its energy efficiency classes from A to G at, as we mentioned, different climate conditions. And also the values should be put here. And also the degradation rate shall be specified. And also the model area.
Yunzhe, you have 1 minute to please wind up.
And also the application range. As we know, some products are still not applicable for this regulation. The first one is BIPV and also perovskite technology. Right now, we are modeling a new calculation method that we can include in the BIPV in this regulating system. So I think this product will be included in the future soon. So after that, it's the carbon footprint. The carbon footprint declaration, there are many points, but the most important should be D, E, F. D shows the calculation principle or calculation rules of the carbon footprint, and E are the stages which the carbon footprint is defined. And the last one, it's the notified body which made this carbon footprint certification. The calculation method is defined in the Annex 4, harmonized rules for the calculation of carbon footprint. It's according to the product environment for footprint catalog rules. So for the PV modules. And if you like to know the details, it's a published standard, so you can check the details. Here are some outline points. First, the scope. It should cover a time period of at least 12 months, or once possible, the data should be updated to 12 months. And the quantified data or the quantified value should be something for 1 kilowatt hour. So the function unit is the kilowatt hour. And it's based on the energy yield of the first year, which is calculated, I mentioned before. The system boundary is defined from the raw material to the model production and distribution. So the boundary we can see at the first stage.
Yunzhe, excuse
the value
me.
is 25 grams.
Excuse me, Yunzhe, can you hear me?
Carbon dioxide.
We are running short of time, so we need to wind up very quickly.
The second stage, it is reduced to 80.
The panel.
So first, the silicon technology will fade out. Then, not all of them, but some efficient technology, and then the efficient monocrystal silicon technology will fade out. Some requirements for the data collection. The blue part, which is mandatory for the company to provide these data from its actual production, so it can reflect the real environmental issues impact. And also some published results. The left side show some published EPD results for different companies. And the right side are the limits set by the European Union. You can see from this data, some companies can meet the requirements, but some of them are not still possible. So last one is the contribution to environmental influence results from different life cycle stages. Actually, although we can see the environmental issues are different, but the production stage always takes the most contribution. Here is some market entry limitation related to green and low carbon policies are listed here. For example, the French carbon footprint, Italian EPD, and also EU battery regulations. These are already valid. Okay, last slide. It's about some introduction and our business stream for TUV SUD. So if you have any questions or interest, you can contact me with my email or with my phone. So any question, please?
Thank you, Yunzhe. I'm sorry, we are really running short of time. I tried to remind you, but I think you couldn't hear me. But thank you so much for that very comprehensive presentation. And it will be interesting to hear more about reliability of PV modules during the panel discussion. So without further ado, let's get now straight into the panel with all the three presenters we